Okay, this is the lesson portion of 6.5. So we're going to be working within this part of the lesson, giving a description from a visual picture. So it says graphs can show a relationship between quantities without using specific numbers on the axes. So you guys are used to having axis numbers out here on each of these lines. Okay, you have to understand that you can also use a graph of lines to demonstrate visually what it would look like without having numbers on there. You just have to understand that as you're increasing, either going up or to the right, that those are increasing in amount, okay? So we're gonna go ahead and first of all, practice some describing. So first of all, if we look at this sample that we have here on the screen, you'll notice that when it goes up from left to right, kind of like slope, it's increasing. Something that levels out is going to be showing a constant or a no change at all, meaning like in this situation, our distance stayed the same the whole time. So maybe we were traveling from one point to another. We stayed at that location for a period of time, and then we traveled back. Okay, so that last portion there is showing a decreasing in distance. Okay, so we're gonna do some really quick matching. So here we've got where we're gonna match. And this is just showing bits and pieces of lines that could actually be pieced together like we just noticed on that previous screen. So we've got, I think, 7 scenarios here, and we've got 7 descriptions. So we've got 3 of them that are talking about increasing. So let's focus on these 3 to begin with. Okay, so where we've got something where it's increasing, whether it's speed or time or whatever. Increasing would be where our line, whether it's a curved line or a straight line, from left to right is going up. So this is going to be an increasing, this would be increasing. C and D are showing decreasing because it's dropping from left to right. E is going up from left to right, so this would be an increasing also. Okay, so those 3 that I have marked in red are going to be our increasing. Okay, then we've got some decreasing ones here for 5, 6, and 7. Okay, so decreasing is where it's going to be going down from left to right. So down from left to right would be C. D is going to be a faster drop from left to right. F is dropping gradually from left to right. And then that leaves us with letter G just showing a constant or a rate that stays the same the whole time. Okay. So let's go ahead, we can actually go ahead and mark this one. This is going to be our constant. Whoops. Okay. All right, so now we're going to go ahead and mark off our red ones. So our red ones, increases at a high constant rate, increases at a low constant rate, and increases at an increasing rate, which means it's getting faster and faster. It's not maintaining the same speed. So a constant would be a straight line. So 1 and 2 are going to have to match for A and B. So a high constant would be where it's going up really fast. Okay. So increasing at a low constant rate, well, constant's going to be a straight line, and low is going to be that letter A, where it's kind of going up at a slower pace or a lower slope. So then that leaves us with letter E to be increasing at an increasing rate. And that was kind of like our rocket scenario that we worked on in our activity, where over a period of time, it's going to constantly get faster and faster and faster. It's not just a constant same speed. Okay, so now for 5, 6, and 7 is our decreasing. So they're going to look very similar to our A, B, C, and E. So decreasing at a low constant rate, that's where it's going to be kind of a low slope. So that matches that one. Decreasing at an increasing rate. So decreasing at an increasing rate, that's the one where it's going to be decreasing and it's going to decrease, changing in speed over time. So that's matching this one right here, letter F. And then decreasing at a constant, high constant rate, that is going to match letter D, because it's going to be dropping at a faster rate, but it's going to maintain that constant or that straight line. Okay, kind of tricky, but it's giving you some things to work off of. So a constant is going to be a straight line and just an increasing rate. If it's changing but yet it's increasing in the rate, it's going to show a curved line. Okay, so let's go ahead and practice some of these. So here we have a balloon scenario, and it looks like if we were to describe this, so if we were to go through and actually describe this scenario, well, we want to go ahead and start off with explaining what's happening in each of these stages. So it's kind of like wherever there's a point where two lines meet, that's where you're going to explain. So here it looks like it's increasing at a constant rate. Whoops. Okay, well then what's happening here on this straight line is it's maintaining where it's staying at that volume. So it's going to maintain that size or volume. Okay, then our next one would be it increases again. So we're probably blowing up the balloon. And then maybe we're catching our breath and we're maintaining that volume again. And then once again, we're going to blow it up a little bit more, or we're going to increase at a constant rate. Okay? So once again, it's kind of using those things that we did on the previous screen to kind of piece together what's happening in this scenario. So I would say this scenario is blowing up a balloon. You know how sometimes when you blow up a balloon and you pause to catch your breath, but you hold the balloon shut, and then you blow up the balloon again and you pause to catch your breath? That's probably what they're kind of explaining in this scenario. All right, so let's go ahead and try another one. Okay, so here it looks like we've got our hair and our length and over a period of time. So here it looks like we are increasing at a constant rate. Okay, so then what happens when there's kind of a break there? There's like a break in time, and it looks to me like if we were talking about maybe this was 8 inches and it went up at a constant rate to say 10 inches. Well, what's happening here? We're back down to 8 inches. So we had a break in time there. So then I would say it decreased. So maybe it instantly decreased. Okay, so in other words, you got your hair cut. Then it increased at a constant rate. And once again, it dropped or it instantly decreased. Okay, so you got your haircut again, and then it increased at a constant rate. Okay. Once again, it's kind of one of those things, it's just having to look at the scenario. If you use your headings, sometimes that'll kind of help you think about like what's really going on here so that you can think of it in a real life scenario versus a picture of a graph. Because sometimes the graph looks kind of confusing. But if you think in terms of, okay, length over period of time and it's my hair, well, what could be happening there? All right, let's try one more. Here we have engine power, and we've got our horsepower and our engine speed. Okay, so it looks to me like it is increasing, and it's not a constant rate because it's not a straight line, but it's just increasing at an increasing rate. Okay, and then it increases, and then it still continues to increase, but it kind of slows that increasing rate. At a slower rate. Okay. So once again, there we're only seeing an increase, but it's not a constant increase because a constant would show a perfect straight line up. Okay, this is showing a curved line, so that's doing an increasing of an increase. All right. Last scenario, it says the graph shows the temperatures throughout the day in 2 cities. Describe the change in temperature in each city. Make 3 comparisons about the graph. So let's start with the comparison. So if I compare, well, it looks like, and I'm just going to do this verbally. In Belfast, our temperature increased, got to a certain temperature, and then slowly decreased over time. And in Newport, we had where it decreased, it stayed at a constant temperature, and then it increased. Okay, so it says describe the change in temperature. I kind of already did that, did both of those together. Okay, so that's it for this lesson. Once again, it just is going to take lots of practice. If you need to, rewind the video and kind of touch back with those ones where we're matching. That might help you with some wording when you get to your homework. So good luck with this.